Okay, so this is a video working through the four most missed questions from our test in Calc BC on Friday, April 24th. And there's only one of these that really got missed heavily, but the other three got missed enough that it's worth talking about. So this first one was number 3. You've got two particles starting on the origin, they're moving along the x-axis, and you're given position functions. So this is horizontal movement, and you're having that described by sine of t and then e to the negative 2t minus 1. For how many particles for how many values do they have the same velocity? And on this one, what you want is these are position functions. So there's a position, there's a position. You want the derivative. So to get velocity, we're going to take a derivative, which would be cosine of t. That would be our v1, I guess, if we're doing the subscript. And then my v2, if I take the derivative of that, negative 2e to the negative 2t. Then the derivative of negative 1 goes away. So these are my two velocity equations. And you want to know for how many t values that those two are equal. So what we want to do is set them equal to each other. The problem is from an algebraic standpoint, if you attempt to do this, you're not going to be able to come up with a solution beyond guess and check. And we're looking from 0 to 10, so it's a pretty wide range of values. So for this one, you're actually going to have to use your calculator. And this was a calculator test. But in terms of the by hand solving, we've taken it as far as we can go. So I went on the TI I've got here and I graphed those two. So you see a bit more on this because of the way they set it up for the computer. But for my blue line, I graphed cosine of x, and then for the red line, negative 2e to the negative 2x. And you can see from 0 to 10, these things intersect 3 times. So the red line intersects the blue line 3 times, and that's really all there is to it. That is what this question is getting at. So for this one, for this first one, the answer ends up being D, and you get 3 intersection points. And that's really it. So that is the first commonly missed question from the test. The second one was number 9. Number 9, it's asking on a continuous function if f of negative 3 is negative 1, so we got a point negative 3, negative 1. And then f of 6 is 3, so we have 6 comma 3. Then the intermediate value theorem guarantees. So they're setting you up here to use IVT, or intermediate value theorem. Intermediate means in between. So they're specifically asking you for what happens in between these two. And the answer ends up on this one being D. So on D, let's see, that one spans the values from negative 3 to 6. So those are our x values. That's our domain. We're saying between negative 3 and 6, you've got to hit you have to see all the y values between negative 1 and 3. They didn't need to choose one. They could have picked any y value between negative 1 and 3. Often when you first learn it in Calc 1, you do it with zeros or roots, but it can be any y value in there, and that's what intermediate value theorem is. A fair number of you chose answer B on this one, which is an incorrect answer. It's using mean value theorem. And for 2 reasons it's incorrect. One, they're saying intermediate value theorem. So they're specifically telling you which one they want you to use. Mean value theorem, what the answer B is finding the slope. If you find the average slope between these two, you do get 4/9. For mean value theorem to work, even if they hadn't asked intermediate value theorem, for it to work, it also has to be differentiable. So it's not just enough for it to be continuous, it needs to be differentiated everywhere. And that's a small point, but you could have a function where you have a cusp or a point on it where you can't take a derivative, and your average slope ends up being 4/9, but you don't actually find anywhere where 4/9 exists. So unless they tell you that it's differentiable everywhere, you can't use mean value theorem. And here they specifically asked you not to. But they wouldn't have had to throw that in there, and you could have had to sort through that either way. So that's really it. There's no other computation to do on this one, and that is the second most missed one. So that was question 9. Question number 19 is a UDV problem. So this is a BC integration problem. You can't do this integral without the UDV method. So U is equal to x. dv is, what would that be? Secant squared x dx. And then du is dx, and v would be tangent of x. So there's my set of information I'm going to use. And again, the way this works is uv minus v du. So uv would be x tan x. And right there, I've got to go A, D, or E. So I can rule out these two. And then I've got minus v du, so minus the integral of tan x dx. So then really, to determine which one of these we're going to be using, A, D, or E, we're going to have to do tangent x dx. And I think it's probably fairly obvious that it's going to be one of these two, either D or E. And the answer does end up being E on this one. We'll show why, but the answer ends up being E. So what we're being asked to do now is to integrate tangent. I'm going to write that as sine over cosine, mainly because I don't have the integral of tangent memorized off the top of my head, but I know what it can be written in. So I'm going to make u equal cosine. Du then is negative sine x dx, meaning this piece of the integral, I've already got a minus out here. I've got another minus right there. That's going to make it a plus. And then it's going to be 1 over u du, because the u here goes on the bottom. The sine x dx gets taken out by the du. And then the negative sign, and actually I guess if I'm being completely algebraically thorough on this, I'm going to divide both sides by that negative 1. So sine x dx comes out and negative du goes in its place. And then the integral on 1 over u, of course, is ln of u, and we know u, plus c, I forgot, and we know that u is cosine of x, so I've got plus ln cosine of x plus c, and then it looks like I was needing to bring down that tangent of x tangent of x. So that ends up being the answer, and actually you all were split between D and E, and I think it was just a matter of tracking the negative through, but that's where that negative comes from. It actually comes from right here. That negative gets offset in the problem right there. So that is the answer, and this was the most heavily missed one, or no, I'm sorry, the next one's the most heavily missed one. This, you guys were pretty split between the two. The most heavily missed question was question number 24, and this one it's kind of confusing how they word it. So it's an infinite series, and we're adding up all these terms, and it is clearly alternating. And then they define it to be this piecewise series, which is kind of odd, and it's a novelty type thing. And they're saying which of these statements are true. So they're saying S converges because the terms of S alternate in the limit as n approaches zero, n approaches infinity goes to 0. That's tempting to choose number 1. However, for alternation to occur, it needs to be alternating and decreasing. Ultimately, they're leading you to think this is right because they're throwing this little piece in there, but that doesn't mean the terms are all strictly decreasing. And that's kind of the novelty piece on this one. The terms are not strictly decreasing. Their overall absolute value on them, they're jumping around. And so we're alternating, but we're not going down and getting absolute value-wise smaller as we go from term to term. So we can't apply that alternating lens, which means 1's out. And we have to then make a decision between 2 and 3, or I guess say none of them work. They gave us that option here. So it either diverges because it's this absolute value decreasing. This is what I was talking about. The next term, the n plus 1, is smaller than the n when the negative's taken away, or when we have absolute value. So it diverges because of that, or it converges, although it's true that this doesn't happen. And that's actually the option that you need to pick on this one. So that is the correct answer, answer D. It's only 3. And the reason is if you look at each piece individually, so if you look at each component piece, this first piece is a geometric that converges. So it's a convergent geometric. The second piece is an alternating and decreasing. So each piece alone converges, which means if we add 2 convergent series together, we get something that's convergent. And that is ultimately all that's being driven home here. But it's such a symbol-heavy question, and there's so many leading mistakes that they put in here that they're taking you down mistake roads, that it totally makes sense why this one was the most challenging for us. But that's the thought process of number 1, eliminating that first one. Number 2, acknowledging that, yes, this second one is true, that we have this relationship where it's not strictly decreasing. However, if we look at each individual component expression, they both converge, both of the 2, and therefore the overall thing converges. that makes number 3 our choice. And that's it for the exam questions.